Okay, let's continue. So I hope Iris, you will appear again. I know that's somehow even. Oh, there you are. Yes, I just received the email. Yeah, so yeah, somehow internet is not just internet is unstable. Somehow Zoom connection is unstable. Somehow I myself don't have a stable connection. Well, I have a stable connection at home, but somehow this Zoom is not working properly. Okay, so let's talk about one more thing today. Namely, it's called the pivot positions and row elimination algorithm. So pivot positions. And row elimination. In a sense, we already covered some of it, just it will be another example here. So what is a pivot position? A pivot position in a matrix A is a location that corresponds to a leading 1 in the reduced echelon form A. Right, so here, so that 1 here, it's the pivot. It's the pivot position, right? And the column where it belongs to is called pivot column. Let's write it down. A pivot, so by position, we mean the location of that element in the matrix, the intersection of the number of the row and the corresponding row in the column. Is a location in A that corresponds to a leading 1 in the reduced echelon form of A. Right, a pivot column is a column that contains a pivot position, right? So here is an example, right? So let's go back to Mathematica because it's easier to type big matrix than to draw them on a paper. So just open it. Where is it? Just 1 second. Oh, there we go. So make it a bit larger. So let's look at the matrix. So we have here a matrix 4 by 5, right? And then let's put some numbers here, like, you know, some random numbers. Let's say this is 0, this is 2, 5, 8, 10, 0, 9, 0, 3. Some matrix with a bunch of zeros in it. And yeah, so let's row reduce this matrix to the pivot position, right? So here, well, we have a 0 here, right? So it's not good. So we need to, well, to put something. So yeah, so pivot position simply means that we need to reduce it to a the echelon form, right? To the reduced echelon form. So first we can swap. I'm just gonna write those matrices in commas. Right, so we can swap the first two rows. The first row goes here. Second row goes back. Right, and then well, we need to make this 4. We need to turn it to a 0. Right, so one way to do it will be to multiply the first row by negative 4/3, right, and then add it to the second row. And so we can do this first row stays, and then this would be 0, and this will be negative 20/3, right, and then it's so here it will be 2 minus 4 times 8 divided by 3. That's minus 26/3. And then here it will be 1 minus 4/3 times 10. It will be minus 37/3. And finally here we get nothing, right? So nothing changes. Okay, so far so good here. And in fact, we can divide the first row by 3, right? So we can write here 1, here's 5/3, 8/3, and 10/3. And so this one is the pivot, right? And this column is the pivot column, right? And turns out that that's all there is here, right? So you can do, there's not much else you can do, because the well, actually this is not quite true. So we can also get rid of this number if you do which we combine the third row with the fourth row, right? So for example, we can well, so we need to get rid of this number, right? So we can multiply. Well, we need to convert 3 into 20/3, right? So this, in other words, we can take this thing, right, and multiply the third row by minus 20 and divide by 9, right? And add it to the third row, to the fourth row. So here we'll get 0. Here nothing will change, and then you'll have minus 37/3 plus 9 times 20 divided by 9, and that's 23/3. So the calculation becomes not so pleasant here, like that. And again, 1 stays 1 because nothing changes. So next, what we can do, so you can see we have the staircase, like there's one step. It looks like there's a 1 step, the 2 step, and 3 step. And now we can divide. We can divide the we can normalize it, right? So we can divide instead of 3, we can get a 1 here. Let's switch next step, right? So we can divide by 3 the third row. So it's 1, and here we have 3. And finally, and here we can multiply by minus 326. So this becomes 1, and this becomes minus 23/26. And this number becomes minus 3 divided by 26. Okay, so far so good. Yeah. Yeah, go ahead. Yes, Iris?
I think it's not really clear for me. I need some time to understand.
Sure. So which part isn't clear? Like maybe I can give you some simple example where the numbers are not so complicated. What do you think?
Yeah. Can you give me an easier example?
Yeah, sure. Absolutely. Yeah, of course. So in fact, what I did, I just took the matrix out of blue, but we can take a slightly easier matrix. Is this big enough, or shall I make it bigger?
It's okay. It's okay.
It's okay. Good. So let's take a simple example. So let's take. Let's take another matrix. Yeah. So sure. Also, it's 0. Minus 3, I have some in the notes. It's a minus 3, minus 6, 4, 9. Minus 1, minus 2. Minus 1, 3, and 1. Yes, go ahead.
Yes.
Minus 2, minus 3. 0, 3, minus 1. 1, 4. 5. Minus 9, minus 7. Yeah, and the rest, let me remove it so it won't be confusing. Okay.
Yes.
So let's take this matrix. Now, can you locate, so do you remember what pivot is? So pivot is just, so we need to reduce this matrix to the echelon form, right? So echelon form,
yes.
And then the reduced echelon form.
Yes.
So first we need to put the arrow, so excuse me, like the first, so the 0 is not okay, right? That's not the echelon form. So we need to swap some rows to sort of turn the 0 to something non-zero. So
yes.
let's maybe switch the first row and the fourth and the last one. It doesn't have to be the last one. It just I take the last one and I put it here, and I just swap them like that. In fact, yeah, let's do it as we had before. Right? So that's the step. So that's the matrix. That's A. This matrix A equal to this. And now step 1. If we swap. Sorry, actually, let me make a new row here. Step 1. Swap rows 1 and 4. Okay. Right. So now remember, now we need to get rid of all these numbers here. So in the pivot column, everything should be 0.
Yes.
So we can do it by this. We can just add the first row to the second row and add twice the first row to the third row. That will take care of that will take care of these coefficients. So first row times, so first row plus second, and first row times 2 plus third. What we're going to get. So can you tell me what will be the second row then? So this will be 0. What will be here? What's
2.
Yeah, 2, and then you just add the right. So then it's 4 minus 6 and minus 6.
Minus.
And then here it's a 0. What's here?
5.
Yeah. And here.
Uh, 10.
Yeah, 10, and then
minus 15.
15, and here it's also minus 15. Right?
It's 15. Yeah.
Yeah, good. So we took care of the first column. Now it's in the echelon form. Right? Now, so the first column is done, so that's good. Now we take the next pivot column, right? So,
yes.
And then in fact, the choice of the pivot here, it's up to us, right? So here in this small submatrix, we can shuffle the rows any way we like, right? So for example, one thing we can do, it's like this form is not unique, right? It's basically it's up to permutation in a sense. So let's take 2 as the pivot element. So
okay.
we'll keep the second row, and we'll eliminate the third and the fourth.
Okay.
So then we do similar step 3. We'll do a similar exercise. We'll we need to multiply by what? So first of all, let's. So it's a kind of trivial step. We just divide second row by 2 because it's all even numbers. All even numbers. Divide second row by 2. We can do that, right? So that will give us 1, 2
minus 3.
And then we'll just write it sort of. Yeah, so then we take a second row times 5. Then minus 5, right? Multiply second row by minus 5 and add to third row, and then multiply second row times 3, right? And add to the third, add to the fourth row. Add to 4. So that will take care of all those things, right? So that will be 0.
0.
Minus 5, right? So that's also 0. Because it's 2 minus 5 minus 10. How about this one?
Minus 30. Minus 30.
Minus 30, so it's 3.
No. 0, 0. 0, 0.
Yeah, that's right. So that's also 0. And the last one, also 0. Yeah. So see, we got that this row is completely gone.
Yes.
Then we're on top. And then how about the last one? So that's 0 because it was by desire. And then here.
0. 0.
Mm-hmm.
Minus 5.
Yeah.
0.
Good. And then finally, the last step was not last yet. So let's swap rows 3 and 4. That brings us to, well, like that. And then also sort of normalize row 3, right? So normalize meaning divide by minus 5. Row 3 after this, so just you're going to put 1 here, right?
Okay.
Good.
So normalize is to change it into 1?
Into 1, yeah, that's just a word that people use, yeah. normal.
Okay.
Right? So what is when you write some formula, you divide by square root of something. That is called, like we say in calculus, right? That is called normalization.
Okay, thank you.
Good. So now that's the so-called, that's the echelon form. Now let's make it a reduced echelon form, right? So what do we need to do? We need to now to see. So these are pivots. This 1, 1, 1, and now we need to
Yes.
need to get rid of these guys and get rid of this 4. So what we're going to do now, we're going to go up backwards. So we'll take the shortest row, this one, 1, 0, and then we'll use it to get rid of these numbers.
Okay.
So if you wish, until now, steps from 1 to 5, in sense we were moving sort of downwards, right? It's like so we're going from the top row after we did the swap to the bottom row, right? So it's kind of up down motion, so up down procedure, and then now we go bottom up. We go back.
Okay.
So and that's sort of bottom up motion will give us the reduced echelon form, right? So far we just have echelon form, but what we need is the reduced echelon form, which will allow us to find the solution. Right.
Okay.
In fact, what we're doing is already called the row reduction algorithm. Yeah.
Okay.
And that's so sometimes what we just did. So here it's called the forward phase. So steps 1 through 5 referred to as forward phase, and next what follows. So now we do backward phase. So let's do it. Step 6. We multiply the third row by 3 and add it to the second. So third row times 3 plus second. And let's do it at the same time. And then third row times 9 plus the first. And so that gives you 0, and this doesn't change. And here that will give you 0.
0.
Because there's 0, minus 7 doesn't change, right? So it's 0 multiplied by anything is 0.
Yes.
Okay, and now let's finally get rid of this 4. So we need to multiply second row by 4 and plus add it to the first row. Minus 4, excuse me, or subtract it, whichever way you want to put it. So that's 0. Then what will be instead of this 5?
Minus 3.
Yep. So that's 0, and then here.
5.
That's right.
It's.
Yeah. So it's 12 minus 7.
Okay.
Yeah. So are we done now? Is it in the desired form? Yep, it should be, right. So that's the reduced echelon form, right? All the pivot columns have all zeros except those pivot positions, and it looks like a staircase.
Yes.
Yeah. Right. So what we have done is known also as the row reduction algorithm. So, and it consists of two phases. The forward phase, when we kind of so first we order rows as we did, right? So that the longmost row with the most number of non-zero elements will be on the top, right? And then we order them in terms of the number of non-zeros. Right? So
okay.
Yeah, so if you think of this as the set of the equations for 5 variables, right? So x1, x2, x3, x4, and x5, does it have a solution or not? If you think of this matrix as the augmented matrix of the linear system of equations, will the system have a solution?
I think I missed the content of the augmented matrix because
Oh,
my
yeah,
internet
okay,
was
yeah, good. Yeah, so yeah, let's repeat that because it's in. Should I get back right? So so here, let me write you. So say we have some system of equations. Let me open it in. Have it in previous file somewhere. So let me write you the system of equations will correspond to this one, right? So so do you know how to multiply matrices, right? So so you have a matrix. So this is the matrix. You know matrix multiplication, right?
yes.
Good. So now let's multiply this by the column x1, x2, x3, and x4.
Yeah.
Yeah. So it will be this thing, right? So see what I did? I removed the last column, right? So so the last column plays the role of the right-hand side of the equation. So this the system of linear equations would look like this. This is equal to that. Right. So in other words, in this case, it will be like this. So it's a system of equations. Sorry. No, something like that. Yeah. So like this is equal to 0. This is equal to 0, and this is equal to 0. And then the last equation drops out. So like you have three, one equation turns out to be trivial. So the claim is that this matrix describes the following system of equations, which has unique solution. You know. Were you online when we talked about unique solutions and stuff, or not? Or no? I don't remember. Where did you? Were you present when I talked about the? We looked at the system of equations from the last class, right?
Yes.
Sorry, no, not from the last class. It was a new one, but then we just would draw a plain. Look, let me show it to you again. I'm just going to share another window. Do you remember this picture?
Yes.
Yeah, so we had a system of equations that looks like this, right? So these are three equations. This one, and that one. Now, we can write these equations as a system of linear equations like this, right? So, sorry, let's do it first. So if you do it like 1 minus 2, 1, 0, 2, minus 8, 5, and minus 5, right? So if you dot that with, if you multiply it by the column vector x1, x2, x3, you'll get exactly, you'll get the left-hand side of these equations, right? And then the right-hand side will be, is the column vector, okay? 0, 8, 0, 8, and 10. Well, let's write it like this, it's minus. So that's equal to 0, right? So these are the same equations, right? So these three equations are the same as these three equations before. Now, what we call augmented matrix, if you include the right-hand side into the last column. So if you do it like this, so put it instead of the first three, we put the last one here. So that is called, so this is the augmented matrix for system of equations A x equals B, where A is this matrix, right? X is this vector and B is that vector. That's just the terminology. Does that make sense?
Yes.
But the augmented just simply means that the right-hand side, right, this vector is, you just put it in the last column. So when you do manipulations with equations, when you do this row algorithm, you do it, you do the same, but when you do the multiply equations by numbers and add them together, right? You do it with the left-hand side and with the right-hand side. So we just write left coefficients to the left-hand side and in the right-hand side in the same matrix.
Okay.
So let's do maybe let's do the pivot. So I think that's where you disconnected. Let's do the the echelon decomposition for this matrix. Shall we?
Sorry. Actually I cannot understand the out 14. Can you see that? Below the B0810, there is out 14.
Oh, it's just the it's like the way mathematics works. It's like out.
No. I don't know the things below the out 14. Yes, this line. Yeah.
Oh, that's just the same. Okay, do you understand this? That's the system of equations.
Yeah, I understand.
So let's do that.
I understand. Yeah.
Good. So, right. So that's the system of equations, which you can write in the form A dot x equals B, where A is this, X is that, and B is that. Okay.
Yes.
And now what we're just doing, it's the same numbers. We just put them into the 3x4 matrix, and that's it. Yeah, go ahead, ask a question. Okay, does it make sense?
I think I need some time after the class to understand.
What part is not clear? So just the name. So we call this augmented matrix for this system of equations. Okay, now sort of maybe to understand better, let's reduce this matrix to the echelon form, shall we?
Okay.
Yeah, okay, that's a. And then, so by doing this, we'll find the solution of this equation. So as this picture suggests that the solution is unique, like the three planes described by these equations, they intersect at one point, right? The solution was, I believe, 1, 0, and -1 or something like that. So let's reduce this to echelon form. So what shall we do first? Now you know what to do.
0.
So that's the pivot of the first column. This is the first pivot. What shall we do then?
I think for the first row, multiply -5 and add the third row.
Add to the third row. Yeah, absolutely. So if you do that, this will disappear. This will be what?
minus 10.
Minus or plus?
Oh, no, oh, no, no.
Multiply by
10,
minus.
10, 10, 10, 10. Yeah, 10.
Yes, okay. How about this guy?
Minus 55.
Yeah.
Yeah, and
That's
10.
And 10, yeah, that's right. Now, let's also, we can simplify things a little bit, right? We can divide by the common, for example, the second row is all numbers are even, right? So
Yes.
we can
Divide.
Yeah, by 2. So we get 1 minus 4 and 4. And then the third row can divide by 5, right? So we can get it
Yes.
2 minus 11 and 2. Right, so that's a bit easier. Okay, what should we do next?
I think add first row to the third row. Oh, no.
No, we'll do that later, right? So remember, first we'll fight the forward procedure. So let's say this is the pivot, and now we need to get rid of, we need to first reduce to the echelon form, and then to the reduced echelon form.
Okay.
So we can multiply second row by minus 2 and add it to the third row, right?
Yes.
So that will be 0. What will be here?
Minus 3.
Okay, and here?
Minus 6.
Yeah. Okay. Yeah, so we didn't make a mistake anywhere. So right, and then again, so we can divide it, right? We can normalize it. So we can divide by 3, and here we can divide by minus 1. Right?
Yes.
Sorry, that makes. No. So that's wrong. No, you cannot do that. You cannot do that because there's 1 here. Okay, so but in the last row we can do it. Okay, good. So that's the echelon form. It looks like a staircase. And now let's get rid of these numbers and that number. So we need to get rid of this minus 4 and this 10, and now we're going backwards, right? So the backwards procedure. What do we do now?
Multiply the row third by 4 and add to the second row.
Second, so get easy. So it will be 0 here.
Yes.
And
at 12.
Yeah, that's right. 12 here.
Yeah.
And then instead of this 10, we'll multiply it by minus 10, right?
Yes.
So that would be
0.
And minus 20, right?
Minus 20.
Okay. And finally, we need to get rid of these 2.
Yes.
By working with the second row, right? So, so we'll multiply second row by 2 and then add it. So it will be 0 here. And what's here? And then
this is 4.
Yeah, that's right. So right,
yes.
So see, this is the reduced echelon form, which means that x1 is equal to 4, x2 is equal to 12, x3 is equal to 2. So here there's a unique solution, right? Because so there, yeah, and now we can good. So you understand how to get that, right? So you understand all the steps. Now let's see what this means, what it means to solve this equation, right? So I'm just gonna write it next to. So what we have done is that we have transformed by row elimination algorithm this matrix we transformed into this matrix, right? That's what we just did together. Okay. So we started with this and ended up with that. Now, so the meaning of this augmented matrix is that it gives you the coefficients in the linear system of equations, right? So if you have a linear system of equations like that, that corresponds to this augmented matrix. So what we have shown is that you can make linear transformations. So this matrix becomes this one, which corresponds to the following system of equations, right? So it's x1 is equal to 4. I believe we made a typo somewhere, so it's not exactly the solution that we had before, but doesn't matter. It's that x2 is equal to 12 and x3 is equal to 2.
Okay, okay.
Yeah, that's what it says.
Oh, I know.
Great. Yeah, I think, yeah, so we learned something today. So yeah, please re-watch the video about the first part where we plotted those planes, right? There's quite a bit of drawing here. Like this is the system when there was no solution. And I believe we should stop here because there's next class. Yeah, so I think next time we could just, did you look at the homework, by the way?
Yes, I received a PDF
Sure,
of
but
homework.
did you start working on it?
Not really.
No, not yet. So I think it's time for you to start, and then we can talk about some. If you have any questions, you can talk about this tomorrow.
Okay, okay.
We continue lecturing. Yeah, sort of. I think it's important that you give me sort of feedback, so I know what is the right pace.
Okay.
Great. So Iris, thank you very much for joining. So I'll see you tomorrow then.
Okay, bye.
Bye.